Welcome to Huawei's Campus Optics IP+ passive optical line solution, a future-proof network choice for 13 years. I am Philip Hu, Network Director of Huawei EBG Indonesia. First, let's take a look at the trends in campus network. Traditional campus deployments assumed the majority of the traffic was horizontal, with service moving data between users and the device, often in the same tier. With the introduction of cloud service, traffic shifts vertically, with users and devices interacting with or through a cloud data center. This calls for a rethink to our new campus architecture, simple and easy to deployment. New service and devices are being introduced every day, and high bandwidth services like video conferencing and CCTV are commonplace. With Wi-Fi 6, we need 10 gigabits connections, and that quickly exhausting the capability of copper. We need a new solution that can support not just the bandwidth demands of the service today, but can continuously evolve to support those services in the future. And this new campus needs to be easier than ever to operate and maintain, with operation and maintenance automation for easy and unified management. Traditional campus network face a 100-meter transmission distance constraint on copper. Campus Optics builds a flattened network experience with 3 key advantages. First, Campus Optics integrates the benefits of IP and passive optical line for a future-proofed platform with better investment protection. Huawei's industry-leading Wi-Fi 6 provides extra broadband of wireless access. The OLT platform is ready for next-generation PON technologies, allowing bandwidth to reach 15G per port in the aggregation, and the call switches can run without change for years because our density is 6 times higher. Second, Campus Optics is green. By using passive material, we save energy by almost 13%, and the flattened architecture component of the solution saves 15% of the IT room space and cabling. Third, Campus Optics converges management, saving labor costs in managing and operating the network. The Huawei Campus Optics solution includes a unified management platform to maintain the whole network, and it's plug-in and play. We live in an eco-conscious world. Copper is limited resource, with more than half is already tied up for various wires and cables in the building. Fiber is made from silicon dioxide or sand. We've got a lot of it. It's 18% power efficient than copper. Fiber's 14 kilometers range, whereas copper 100-meter range is 400 times better. For the bandwidth, fiber has no limitation, while the copper only can reach 10 gigabits in maximum. And the fiber lasts more than 13 years. That's 4 times longer than copper. With deep fiber, we are penetrating farther than ever before to put the benefits of fiber in action. Traditionally, fiber was deployment from the IT room to the building, to the floor, and that's it. But we can push it even deeper, past the floor, into the room, right to the desk, and even in some cases, to the end terminals. Now let's take a look at which products are included in the campus optics solution. The 5G powered Wi-Fi 6 can support 16 transmission, 16 receive spectrums, provisioning the world's first 10 gigabits Wi-Fi. Cloud Engine S-series switch, providing access, aggregation, and call switches for the campus. Especially for the call switches, it can support 288 high-density 1 gigabits ports. The quick switching capacity is 6 times of industry average. Optical access platform supports the 10G-PoN and 14G-PoN. We also provide the converged platform for the optical and LAN network operation and management in campus optics solution, named iMaster NCE Campus. This platform can generate the topology automatically, give a real-time network visualization, and also do the access control for the authentication management. With this platform, we can achieve auto-commissioning and provisioning, plug in and play. Campus Insight is a component for the iMaster NCE platform. It is an analyzer tool providing the intelligent operation and management in 3 ways. First, it shows 7 experience information of the network in real time, which can help you to do the network evaluation. Second, based on big data and AI technology, the tool supports quick playback and achieving minute-level troubleshooting. Third, the tool supports smart radio frequency tuning for radio frequency, power, and channel optimization, which can improve the Wi-Fi performance by 15%. Every campus has its own specific requirement for bandwidth, size, latency, energy consumption, and security. Campus optics provides the architecture innovation needed for campus of today and the future. For offices, it provides quick deployment with easy upgradability. For classrooms, it provides quick flattened. The flattened architecture means fewer loads and faults and simplified operation and maintenance. For hotels, it delivers multi-service in a single network with optimal cost. And for airports, campus optics has anti-electromagnetic interference with long-distance coverage. Campus optics solution can be used for all of these 4 scenarios. Next, let's look at how campus optics can be used for education campus deployments as an example. There are 3 main scenarios. First, there is the classroom and office, where there is a variety of devices, including IP cameras, PCs, intelligent whiteboards, attendance machines, and Wi-Fi access points. The optics ONU easily enables all of this with a single fiber to each classroom or office area. Next, there is a dormitory where the optics ONT provides both wired and wireless access for TVs, tablets, laptops, smartphones, and voice with built-in Wi-Fi. It can even provide connectivity for native television. And finally, Safe Campus, where Huawei industry-grade ONU provides outside connectivity for IP cameras and wireless access points. 1 terminal per class for all service with easy plug-in and play and one-click provisioning and for 100 Mbps everywhere using Wi-Fi 6 means you get high bandwidth service online in one day. In the classroom, deployment is easy with a single fiber, providing capacity for all services today and in the future. With the actual high bandwidth multi-G switch, students can now realistically stream high-definition video over PoE-powered Wi-Fi 6 access points, adding a new dimension to the classroom. Being a student in a dormitory means you have demands for all same service you would have at home, but in high-density environment. With a single fiber and ONT, each room can provide Wi-Fi, internet, telephone, and video services with a 13% decrease in TCO. Using a unified SSID, students have free roaming with automatic switching for network coverage with no interruption. And during smart operation and maintenance, Wi-Fi radio frequency power and channel optimization, and auto concurrency queues, the service experience is visible, allowing for proactive maintenance at multi-level adjustment for services. The iMaster NCE platform can help you monitor site and topology. You can monitor the health status for all the devices in each site. And you can also get the real-time information for both IP devices and PoL devices, as well as the link status shown on the topology. For the commissioning, no need to configure on the GPON device. Even only the IP background engineer can do the configuration for the PON through NCE platform. Once our configurations are pre-configured on the NCE, the ONT device just need to power on, plug in, and play within 1 minute. Huawei is very strong in campus optics network solution. Huawei have 13 R&D and innovation centers with more than 7,000 R&D staffs all over the world. Huawei invests more than $1 billion each year in the R&D. Huawei also do a lot of contributions to the IFC standards, ranked #1 in datacom field with 403 submitted IFC drafts, and #1 in NG-PON standard with 14.6 approved documents. Thanks for all of this, Huawei ranked #1 market share for PON and WLAN, #2 for the Ethernet switches. Okay, that's all for the campus optics solution. Now let's watch a video for campus optics practice in Huawei Xi'an Research Center.
Welcome to Huawei R&D Center here in Xi'an, one of 3 locations where we've deployed our campus optics solution, and thousands of my colleagues are currently benefiting from its capabilities. Let's go take a look around and see what's going on. We're here in front of the V5 office building where about 2,000 R&D staff work. We've deployed our campus optics solution here, and to compare and observe the tangible benefits of this solution, we've also deployed a traditional Ethernet switch solution. Okay, let's go take a look around and see how these 2 networks work. These are the structural diagrams of the 2 networks. The Ethernet solution consists of an equipment room, backbone, management, horizontal cabling, and work area subsystems. The main devices are core switches, the aggregation switch, and access switches. The core switches are connected to aggregation and access switches using optical fibers. The access switches are connected to terminals using 50 to 80 meter long Ethernet cables. Similarly, the campus optics network solution consists of an equipment room, backbone optical cable, distribution subsystem, access optical cable, and work area subsystems. Its main devices are core switches, OLTs, optical splitters, and ONUs. Optical fiber connects the core switch to ONUs, and Ethernet cables are only used to connect ONUs to terminals. There are two key differences between the two solutions. First, the campus optics solution uses passive optical splitters instead of the active access switches and aggregation switch used in the traditional solution. Second, in the campus optics solution, optical fibers are moved downward to the ONU level, and network cable length is shortened from dozens of meters to just a few. This feature is called optical in, copper out. We've come to the Ethernet equipment room. This is one of 4 in the building, and it's capable of supporting 500 employees as they go about their day. And there's a lot of equipment here. I can count 7 cabinets housed in this fairly sizable room. The switches in these cabinets are active. They need plenty of power and generate quite a bit of heat. And that means that we need to keep the air conditioner running all day long, which is quite an expense. To hold this massive bundle of network cables, we need to have a large cable tray. And remember, this mess of network cables can only support 500 people working. These cables are distributed from access switches to the information points on desks. Now, we've seen the Ethernet equipment room. Let's head up 1 floor to the campus optics equipment room. We've come to the 5th floor of the building where the campus optics equipment room is. There are only 2 cabinets here compared to 7 in the Ethernet equipment room. And these 2 cabinets are capable of supporting 2,000 employees. So that's 2 cabinets for 2,000 employees versus 7 cabinets for 500 employees. And here we have the OLT cabinet on the right and the ODF cabinet on the left. If we open the OLT cabinet here, we can see that only about half of the space of the cabinet is used. So at the top we have the UPS, and then we have the OLT here, and they're used to help ensure Type B dual homing protection. Now if we open the ODF cabinet here, we can see at the top we have the ODF, and then the rest of the cabinet consists of the 2 to 16 rack-mounted optical splitters. The optical fibers are inside this cable tray. They come from the optical splitters here, and then they're transferred through the cable tray to information boxes at office desks. There aren't very many of these optical fibers, and since they're also quite thin and light, we only need this small cable tray. There's only one more thing to add here, and that's that our air conditioner is switched off right now. We don't need to run it 24/7 because there are only 2 devices that produce any significant heat, and those are the 2 OLTs. The ODF cabinet is purely passive. It doesn't generate any heat at all, and it cools down naturally, which saves us a lot in electricity fees. Okay, let's have a wander over to the office area. Optical fibers from the optical splitter are transported to each desk via this underground cabling duct, and you can see those optical fibers in this glass cabinet. Now if we look inside, we can see 2 different colors of cables. We have the gray Ethernet cables, and we have these white cables bound with the green tape, which are the optical fiber cables. We also have another kind of white cable here, which are telephone lines. Now in this example where we're supporting the same 250 office desks, the difference is clear. There's a much larger bundle of the grey Ethernet cables versus a much smaller bundle of the white optical fiber cables. The information box installed under the desk is where the optics style ONU is stored. It's small, but it can carry several services: cloud desktop, IP phone, wireless access point, video surveillance camera, printer, video conferencing system, and access authorization. Let's look at some numbers. For the same number of users, 2,000 network cables are used in the switch solution. The width of the cable tray is 40 centimeters. In the campus optics solution, there are 500 optical fibers, and the width of the cable tray is just 10 centimeters. Over 30 cubic meters of equipment room space is needed for the Ethernet solution, but the campus optics solution needs less than 1.5 cubic meters. The Ethernet solution takes twice as long to deliver as the campus optics project. Campus optics requires just 1/3 of the engineering investment, half of the monetary investment, and energy consumption is also 1/3. Okay, thank you for joining me on this tour. That's all for now, but if you want to learn more about the campus optics solution, you can go to e.huawei.com or contact your local Huawei representative. If you have any questions or feedback, please post in the comments section. Thank you for joining us.
My name is Philip Hu. Thank you.